In this example, we're measuring the height of a bridge without using a ruler. We're simply dropping a rock from the bridge to the water below. According to the problem, it takes 1.2 seconds for the rock to fall. So we know the time in the problem. Do we know anything else? Yes, we do. We know the acceleration. The rock is falling due to gravity. We know the acceleration due to gravity. In English units, it's 32 feet per second squared. In metric units, it's 9.8 meters per second squared. Those two values for acceleration are identical. They're just expressed in different units. Okay, well, we know acceleration and we know time. From that, we can calculate distance because we know that distance equals 1/2 acceleration times time squared. All right, then, let's use this equation. The time is 1.2 seconds, so we can put that in for time. What about acceleration? Well, the acceleration is either 32 feet per second squared or 9.8 meters per second squared, depending on the units we want. Well, if you look at the problem asks for the answer in meters. So we had better use 9.8 meters per second squared. That'll give us the right units in our answer. So our distance then is 1/2 9.8 meters per second squared times 1.2 seconds squared. All right, now we have to evaluate this equation. First, we have to deal with the square. Remember what a square means. It means you just multiply the number by itself. So 1.2 seconds squared is like 1.2 seconds times 1.2 seconds. So I can rewrite this equation as distance equals 1/2 9.8 meters per second squared times 1.2 seconds times 1.2 seconds. Well, remember, when we do math, we can group the numbers together. So 1.2 times 1.2 is 1.44. And then we can put the units separately. Seconds times seconds is seconds squared. So the equation turns out to be distance equals 1/2 9.8 meters per second squared times 1.44 seconds squared. Now look what happens. The seconds squared cancel. In the first unit, I've got meters per second squared, so the second squared is on the denominator of that fraction. On the second unit, I just have seconds squared. Well, that's like seconds squared over 1, so that's in the numerator of the second unit. So I can cancel those. Seconds squareds cancel with seconds squared. And I'm left with just the unit of meters. That's good because that's what I wanted my answer in. So now all I have to do is deal with the numbers. 1/2 times 9.8 times 1.44 is 7.056. So the distance is 7.056 meters.